All right, so we are going to go through these together. We're going to use some of the things on the screen we talked about after we watched our video. So let's look at number 1. And like I said, I am going to put it on in my notebook so that you can see it. We may also need a periodic table, which we should have one somewhere. Let me pull one out really quick. If you do not have your periodic table, then we will pass out a couple here in a second, or you could look one up online. That works too. There it is. Okay, there's the one that we had for our class. So uranium-235 undergoes alpha decay. Well, how are we going to do this problem? First of all, we need to title our page. And the one that we're going to talk about first is alpha decay. And that's really the one that we're going to focus in on. Okay, alpha decay happens when there are too many protons and too many neutrons. Okay. So the unstable atom throws out a helium nucleus. So a helium nucleus has a mass of 4 and an atomic number of 2. So you might say, I don't remember this. This was from a long time ago. Well, let's review it and make sure we understand. This is the atomic number. And this equals the protons. This is the mass number. And it equals the protons plus neutrons. Right? So now we can go on and do our problems. The first problem says uranium-235 undergoes alpha decay to produce thorium-231. So uranium, the 235 is the mass number. And we're going to look at our periodic table and see uranium has an atomic number of 92. So the 92 would go here. And we know it's going to undergo radioactive decay. Now, what did we just say it throws out if it undergoes alpha decay? Helium. So we're going to have this helium atom plus something. So here's where the math comes into play, right? What's 235 minus 4? So 235 minus 4 is 231. Right? So that's part of our answer. And then what's 92 minus 2? 90. All right, so then we might say, well, I don't know what that is. Well, look on your periodic table. Number 90 is thorium, so we're going to put a TH with it. And we go back to the problem that we had here. Uranium-235 undergoes an alpha decay to produce thorium-231. Now, do we match? 231 is our mass number, so yep, we match. All right, let's look at number 2. Actually, before we go on to number 2, let's write ourselves some notes. We subtract the helium. Okay, so 92 minus 2 equals 90, and that's right there. 235 minus 4 is 231. And that's right there. So let's go ahead and look at number 2 now that we've written ourselves some notes. I know. When protactinium-229 goes through 2 alpha decays, francium-221 is formed. All right, so we know that 229, I'm going to move down just a little bit. 229 is the mass number. And protactinium, well, we got to find what is its atomic number. Right there's protactinium is 91, and we're going to use the symbol Pa. 91. Now it says 2 alpha decays. So we can do this one of 2 ways. We can either go through it twice, which is the easiest way, or we can subtract it all at one time. So let's do it the easiest way. And that is really the way it might happen. So what am I going to get? What's 229 minus 4? Right? What's 91 minus 2? 89. So this math isn't difficult math. It's just you have to know what to do with it. And so number 89 is actinium. So that's an AC. And then AC is going to undergo, because it said 2, here's 1, here's 2. In our problem, it says it goes through 2 alpha decays. So we're going to throw out another helium atom, or nucleus, another helium nucleus. What are we going to get? It's 225 minus 4, 221. 89 minus 2, 87. So then we come back to our periodic table, find 87, francium, Fr. And that matches what our question says. Francium-221 is formed. Okay. So let's look and see what number 3 actually says. Number 3 says uranium-238 undergoes alpha decay. Go ahead and try that one on your own. Okay. Try that one on your own, and then we'll come back with an answer here in just a second. All right, so I finished number 3. Is that what you got? Okay. Notice we had 92 minus 2 is still 90. So just like in number 1, we ended up with thorium. But thorium can have different mass numbers because there's different, just like uranium had different mass number. Ends up differently. All right. I would like for you to go ahead and do number 4 on your own. So you're starting with samarium, and I'll get you started.